Good evening, ladies and gentlemen. I have the great honor and privilege to welcome you to this evening's STEAM Christmas lecture. This lecture that you're going to see today is very much a collaborative effort. It involves colleagues from the Faculty of Education, Health and Wellbeing, from the Faculty of Science and Engineering, and from the Faculty of Arts.
Oh, absolutely brilliant. Now, welcome, as I said, to our STEAM Christmas lecture. Tonight, what we're going to do, we're going to sort of look at STEM. We're going to look at science, technology, engineering and maths. But we're not going to sort of look at a traditional way of that sort of acronym. What we're going to do, we're going to add the creativity, we're going to add the arts back into STEM, this science, technology, engineering and maths, to make STEAM, to make our STEAMed Christmas lecture. Now then, so I'm a pantomime dame, and it's quite a lonely existence here on stage. You know, the lights, the smell of the grease paint. And it is lonely when I'm up here. And, excuse me, it's a bit difficult when you're as big as me. So what I want you to do, every time you see me on stage, ladies and gentlemen, I need to know that you love me. So what I want you to do is shout for me just this one thing. All right, gorgeous, show us your chest tubes. Right? And I want you to shout it as loud as you can. Okay, so after 3. 1, 2, 3. All right, gorgeous, show us your test tubes. Okay, so that's what I want. I know you love me then, ladies and gentlemen, because it is a very lonely place. But I think we warmed up now, and I think it's time to get on with our STEAM Christmas lecture.
So if you would ask a physicist what is sound, he would probably give you a picture of something like that. This is a magnified representation of the air, the ambient air, which is around us. Each little point represents a molecule of the gas. And if we have a membrane that puts this gas in motion, it will generate some disturbance which will propagate up to some point where we have someone who listens at the sound. Okay, the important things to take into account here is that although something is propagating indeed, and it is propagating through the medium, through the air, there is no actual transfer of matter. If you look at one atom in particular, some of them have been put in red so that you can track them, you see that the atom stays where it is. It fluctuates in time, but it doesn't actually move. What is propagating, therefore, is not the actual gas, it's information through this gas. And we can, in this way, by changing the frequency, hope to form a resonant wave, and this is what it's doing now. Maybe you can tune the frequency and try to look for, but this one is pretty beautiful. So you see we have perfect deflation here and very constructive stuff. So the wave is bouncing back and forth, forming this stationary pattern, and by putting the fire, given that the pressure changed, we can actually this time visualize the wave.
And we're going to talk about time travel. And we're going to see that time travel is possible. And in order to see that time travel is possible, we will need an audience volunteer. And the way she's going to do it, don't be frightened. You'll come back about 20 years older, but you'll be able to drive. You'll probably be married, maybe have some children, but nothing to worry about. We can send you back. It's totally fine, totally fine. And in order to move the clock, we're going to dim the lights. It's going to get very dark, but don't worry. Let's think about what the light clock does for Paige and what the light clock does for you in the audience. And if we can raise the lights again, we look at the picture to help us understand. So from Paige's perspective, the light clock keeps ticking vertically, up, down, up, down. But from your perspective, it makes a zigzag pattern. But the principle is the same. If the speed of light is constant, what's happened with Paige and her light clock? From her perspective, the beam goes up, down, up, down. But for you, it's traveled further. Now, if the speed stays the same, as Dangerous Dave and Nurse Nitro are illustrating so beautifully here, that means that time really did run slower for Paige than it did for you in the audience. And that was Einstein's great discovery, that time is relative. And from there, his theory of relativity came.
Now, I'm going to show you some of the chemical elements today, and I'm going to show you some of their properties, because all chemical elements are unique. What we're going to do today, we're going to look at 2 different properties of elements. One is how elements can change the colour of a fire, and the second one will be an explosion. So we're going to look at some gases, we're going to mix them together and make a very dangerous bomb. The first one I'm going to show you is potassium. And this should give a nice lilac colour. And this time we're looking at strontium, so a completely different element and a completely different colour. This time it should be red. Oh, that's quite explosive as well. I like that one.
Okay, are we ready?
3, 2, 1.
Nothing happened. Rubbish.
We fooled you. Now, do you know why that nothing happened? Because oxygen's an excellent oxidizer, but it's got nothing to oxidise. So what we're going to do now, we're going to use an oxidant, an oxidising agent, and we're going to add it to a fuel.
Okay, are we ready?
And we're going to set off a hydrogen-fuelled bomb in the arena theatre.
Okay, fingers in ears, everyone. Okay,
5,
5,
4, 3, 2, 1.
on.
No, you was warned. Oh, I thought I'd gone deaf then, but I've got these on.
Thank you. So we are going to take a very simple element and put it into the band and see what happens. So, are you ready, band? Just dissect this. Ready? Let's have that bass note. Ready? Adam, me and you. 2, 3. Doon dan dwee doo ah. Doon dan dwee doo ah. Doon dan dwee doo ah. Doon dan dwee. I think we need a bit of Scarlet to come in as well. Doon dan dwee dan doon. Some altos as well. Doon da 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 da. 1, 2, 3, 4. Doon dan dwee doo ah. Doon dan dwee. And a little bit of guitar maybe. Shall we try it? Doon dan dwee doo ah. Doon dan dwee doo ah. Now we're going to throw in some double bass. More keys and the top part, and some beatboxing as well. 2, 3, 4. Cha-cha, cha-cha, cha-cha. Doon dan dwee doo ah. Doon dan dwee doo ah. Doon dan dwee doo ah.
Ain't nothing but a turkey, getting stuffed all the time. You ain't nothing but a turkey, getting stuffed all the time. So have a Merry Christmas with your mistletoe and wine.
Give me a place to stand and I will move the earth. And I'll be talking about levers and how we use them to move and to move things. So what Archimedes meant by this statement was if he had a firm place to stand, a fulcrum or a pivot point, and a long enough lever, he'd be able to move the earth. Fantastic. What you've just seen there is an expert performance from Natalie and Connor, both members of the GB Visually Impaired Judo Squad. Let's give them a big hand. Okay, one of the throws you saw there was the hip throw. During the hip throw, the thrower uses their hip as the fulcrum, the lever arm is the length of the opponent's upper body, and the thrower applies a force at the top of the upper body to rotate their opponent forwards and downwards. Now, the load in this case is the weight of the opponent, and if the throw is done correctly, then the weight acts in the same direction as the thrower is applying the force, and that happens. Nice, easy throw.
Right, but if we move that fulcrum and give that lever a longer moment, if you like, and make it more of that sort of second-class lever, we should be able to move the incredible bulk of Mrs. Hoof-Hearted with relative ease. So let's just push down. Here we go. And see if we can fire him up in the air. 1, 2, 3. Push on! Woo! So there we go, ladies and gentlemen. Did that get you in the face?
That got me in the face.
Did it? Oh, I'm really sorry. Let's give our volunteer a round of applause, ladies and gentlemen. Thank you, ladies and gentlemen. Thank you. Good night.